Hey guys, it's Miss Walker. I hope y'all are having an amazing day. I miss all of you. I can't wait to see you again. Um, so today we are going through inequalities. They're very similar to the equations that we've been putting in the calculator. So let me show you an example. So, like the equations that we've been putting in the calculator look like this: mx plus b equals mx plus b, where on one side of the equation we have a slope and a y-intercept, the other side we also have a slope and y-intercept. The only difference really with these inequality problems is that instead of an equal sign, you're going to have an inequality. Those look like this. That would be less than, that would be greater than. They can also look like this. If you have less than or equal to, greater than or equal to. And just to kind of review how you read the inequalities and how you know how to interpret them, a lot of people have said that they have learned about inequalities by looking at it as an alligator mouth, where the alligator likes to eat the bigger number. Okay. If that helps you, remember it that way. Okay. One of the things that I like to point out, so let's say if you have this inequality, the thing that I like to point out is that the bigger side of the sign points to the bigger number. The smaller part of the sign points to the smaller number. And so it works both ways. You don't have to remember like the bigger side only eats like the bigger number. You actually can look at both sides and know about what's going on. Okay. So that's just one more way to help you remember that. In this first problem, we are going to work through this step by step. And that's what all of these boxes are for. It's just one problem, but we're going to break it down into steps. Step 1, gather all the evidence. What do you know? So let's go ahead and read through the problem. Hannah is throwing a birthday party and wants to give lollipops out as party favors. She invited 25 people to her party. Okay, that seems like it's important. So I'm going to underline that. She has budgeted $30 for party favors. That definitely seems important, her budget. And we know that lollipops cost $1.20 each. That seems important. Do you have enough lollipops for all the people you invited to your party? Okay, so here's the information we gathered. 25 people, budget of $30, and lollipops cost $1.20 each. Okay, so the next thing that we need to think about is how would we write an equation like in this form, the mx plus b form? Well, we have to determine first, what is the changing amount? What is the slope? Your lollipops are costing $1.20 each. That tells me that that would be the slope because it's going to change every time you buy a new lollipop. So $1.20 X. And we have a budget of 30. That means we cannot spend more than 30. We could spend anything less than 30 up to exactly 30. So that tells me that 30 is the highest amount that we are able to spend. 30 is the biggest part, but we could also get equal to 30. Okay. The money we spend on lollipops over here has to be less than 30 or equal to 30. Now, we kind of already described this verbal model. Basically, what we're doing here is our 120 is the cost per lollipop. X is the number of lollipops. All of that, the cost has to be less than or equal to the budget. And our budget is $30. Okay. I'm going to go ahead and let's cross out step 4. It's basically the same thing that we just talked about. So now we want to solve the inequality. The way we're going to do that is go into our calculator into Y1 and put in 120x. Make sure you put that decimal there. Y2, we're going to put in 30. So let me go ahead and show you that. So just as a review, you go to Y equals. We're going to put in 120x. And on Y2, we're going to put in 30. Look at your graph. See if you can see the intersection. I cannot. So I'm going to zoom out. Now I can see the intersection. So now I can do second, trace, 5, enter, enter, enter. And our x equals 25. So my answer to solve this mystery is that I could get 25 lollipops with my $30. Now, if I'm going to graph this, it is a proportional relationship. It's 120x plus 0. Ooh, that line does not look straight. And it goes on forever. Meaning I could buy 10 lollipops, figure out the cost. I could buy 1,000,000 lollipops and figure out the cost. All of those data points would be on this line. The 30, did you notice in your calculator how it was like just a straight line across? That is like your budget. That is your limit right there. Once you hit that limit, that is where 25 lollipops is. So one thing we talked about in class was, what if your budget was higher? If your budget was $40, you would be able to buy more lollipops. You would be able to move down the x-axis and get maybe 30 lollipops, maybe a little bit more. I don't know. I haven't done the calculations here. But see how that works? You could buy anything less than 25 lollipops or up to 25 lollipops. Okay? So let's write a sentence to answer the question. The question was, do I have enough lollipops for the people I invited? Yes, I can buy up to 25 lollipops. So I do have enough for the people attending my party. Okay. One of the big things on inequalities is that you really think about the real world situation part of it. Okay? Think about what that limit is and how that works with the problem. Like, for example, if you have 25 to spend at the fair, that is the most you can spend. Admission is $4. That seems like a starting point. Rides are $150 each. That sounds like a slope. Okay, so you build that equation, and instead of that equal sign, instead of that equation equaling 25, your money you spend at the fair has to be less than or equal to 25. I can spend $10 at the fair. I could spend $25 at the fair. I could spend anywhere in there, but I can't spend more than 25. Okay, that's where you want to really think about which way that inequality sign is going to face. All right, guys. I hope y'all are having an awesome day. Reach out if you need any help. Love you guys.